Hi, my name is Emiliano Campagnolo. This talk is titled Pre-Nichols Algebra of diagonal type with finite Gelfand-Kirillov dimension. This talk is based in 3 works. One already published by Andruskiewicz-Sanmarco. The other 2 we did with Angiono and Sanmarco. One is already published in arXiv. Okay, in this talk, fix K, algebraically closed field with characteristic 0. Braided vector space is a pair B, C, where B is a vector space and C that satisfies the Jan-Baxter equation is this. C, in this case, is a braid of B. If B is a braided vector space and consider the usual graduation of tensor algebra, then ρ, given that this is a presentation of the group of the braids. And we have this definition, let B braided vector space and omega defined like this, where M is a section of Matsumoto, denoted J with this gradation, and defining the Nichols algebra of B by this quotient, and the Nichols algebra admit the following gradation. Okay? A Jeter-Differ module over Hopf algebra H is a vector space B with H module and H comodule structure with the following compatibility. A Jeter-Differ module morphisms is a linear map that preserves the module and comodule structure. The Jeter-Differ modules over H conform a braided category which denote this. If B is a Jeter-Differ module, we consider C, given that this is turned out that C satisfies the Jan-Baxter equation. Therefore, B results is a braided vector space and we can define the Nichols algebra B. Okay. A Pre-Nichols algebra of B, Jeter-Differ module, is a graded Hopf algebra in this category with this gradation, where we have the following morphisms of Hopf algebra in this category. We have this epimorphism and this epimorphism, and the definition of post-Nichols algebra is analogous with these morphisms of Hopf algebras in the category of Jeter-Differ modules. Okay, let Q and Xi a base of vector space B. We define CQ by the flip in B tensor B multiplied Q and result that CQ satisfies the Jan-Baxter equation if a braided vector space B satisfies that C equal to CQ for some Q, then we will say that B is of a diagonal type. And BQ denote the Nichols algebra of B. Okay? Let B a braided vector space of diagonal type. The Dinkin diagram of Q is the graph given by the set of vertices is the first theta numbers. Furthermore, the vertex I is indexed by QI. Vertices ij are connected by an edge if and only if Qij, Qji is not equal 1. Also, if Ej is an edge, it is indexed by Qej, Qji. Okay, this is the motivation for our problem. Let gamma group in work by Angiono, Andruskiewicz, and Heckenberger. The following scheme is followed to classify the Hopf algebra of coradical gamma. First, classify finite-dimensional Jeter-Differ moduli such that the Gelfand-Kirillov dimension of the Nichols algebra is finite. And second, for all B of 1, classify post-Nichols algebra of B with a Gelfand-Kirillov dimension, with finite Gelfand-Kirillov dimension. And 2 is related by classifying all Pre-Nichols algebra of B with finite Gelfand-Kirillov dimension. We work on this problem when B is of the diagonal type. Okay, let B a braided vector space such that the Nichols algebra BQ satisfies that the Gelfand-Kirillov dimension of B is finite. All pre-Nichols algebra of B form a poset pre-B with the tensor algebra of B is minimal and the Nichols algebra is maximal. Denote this the subposet of pre-B with all finite Gelfand-Kirillov dimension pre-Nichols algebra. We cite that a pre-Nichols algebra is eminent if it is a minimum of this poset. And calculating eminent pre-Nichols algebra hat B reduce the problem of finding pre-Nichols algebra of B to finding quotients of hat B. In work of Andruskiewicz and Angiono, the braidings of diagonal type are grouped into the following types: Cartan type, supertype, standard type, modular type, supermodular type, and UFO. The problem of finding eminent pre-Nichols algebra is finished of Cartan type by Andruskiewicz and Sanmarco, and the case supertype, standard type, supermodular type, UFO are finished with Angiono and Sanmarco. We have this definition by Ivan Angiono. The distinguished pre-Nichols algebra of BQ results from removing 4 kinds of relation and adding quantum relation in the given presentation. Okay, the theorem that we prove is the following. Let Q a matrix of diagonal type with connected Cartan matrix. Suppose further that Q is not of type and D with Q equal to -1. A2 type with Q is a root of unity of order 3. A3 super type with these parameters and Q is a root of unity of order 3. And G2-3 type with any of the following thinking diagrams. Then the distinguished pre-Nichols algebra is eminent. To prove these results, we need this conjecture. The root system of a Nichols algebra of diagonal type with finite Gelfand-Kirillov dimension is finite. The classification of all matrices with a finite root system was proved in work by Heckenberger. Also, we have this theorem by Andruskiewicz, Angiono, and Heckenberger. If theta equal to 2 or B is a Cartan affine type, then the conjecture is true. Moreover, it holds in general for Cartan type, and there are advances for theta equal to 3. This is a work in progress by Angiono and Garcia Iglesias. Okay, this is the sketch of proof of the theorem. Let Q a braiding matrix with connected thinking diagram, theta grid that or equal to B is associated braided vector space with a fixed basis xi, and B is a Pre-Nichols algebra of Q with a Gelfand-Kirillov dimension finite. We determine the condition under which some defining relations from the presentation of Nichols algebras in a theorem by Angiono are annihilated in B. For a given relation xu, the strategy of the proof is the following. First, we suppose that xu is not equal to 0, and after we check that xu is a primitive element, or we assume this fact. Next, let W be a braided vector space of the primitive elements. Then the Gelfand-Kirillov dimension of the Nichols algebra of W is finite. We compute the braided matrix Q of this braided space. Then the Gelfand-Kirillov dimension of BQ is finite. And the last, on the other hand, we prove that the Gelfand-Kirillov dimension of B is infinite using previous results, so we had a contradiction, so xu equal to 0. Okay, this finishes the proof, or my result. Recall the theorem. Let Q a matrix of diagonal type with connected Cartan matrix. Then the distinguished Pre-Nichols algebra is eminent, but we have these exceptions. So we next we study the exceptional case where eminent Pre-Nichols algebra is not the distinguished one. This result is by Andruskiewicz-Sanmarco. Consider Q of type A2 with Q is a root of unity of order 3. Let hat B defined like this. Then hat B is eminent Pre-Nichols algebra of Q. Moreover, the Gelfand-Kirillov dimension of hat B is 5. Next, consider Q of type A3 with these parameters. Let hat B define it like this. Then hat B is eminent Pre-Nichols algebra of Q. Let XU define like this. The set B is a PBWB basis of hat B, so the Gelfand-Kirillov dimension of hat B is 3. And consider Q of A3 type with these parameters. Let hat B define like this. Then hat B is eminent Pre-Nichols algebra of Q, and the set B is a PBWB base of hat B, so the Gelfand-Kirillov dimension of hat B is 3. And consider Q of type G through 3 with this thinking diagram. Let hat B define it like this, where XU is that and XB is this. Then hat B is eminent Pre-Nichols algebra of Q. The set B is a PBWB base of hat B, so the Gelfand-Kirillov dimension of hat B is 6. And the last, we are current working of the case where Q of the type He2-3 with thinking diagram this. Okay, this is finished. Thank you very much.